test today?
Yep, that's what we're gonna do today.
So that if like this crashed.
And I'm gonna upload lectures from yesterday, and then free up some space on my hard drive. There we go. And we have enough space for today, so that's all good. All right. So what was the major challenge? What was what made this homework assignment more difficult than the other ones?
Random one is.
Sorry?
Random one is a random one. No.
Sorry?
Random. Making
Random?
random number that because when the computer gets a random. So I guess it's stuck in that part.
But it's not supposed to be random.
Yeah, it's not supposed to, but I get stuck in that part of it.
Okay. So did you get it to generate the possible patterns and then
Yes.
use a filter to?
Yeah.
Okay.
Connecting those two things together just a little bit less fun.
Right. It's the concept that counts, right? But are you guys encountering any specific challenges? When we're doing this homework assignment.
It just wouldn't work like I told it to.
Sorry.
It wouldn't work right.
Yeah, well, like kids, right?
No.
Well, my kids anyway. Except in this case, it is logical. There's a reason. You find that reason, and you can then tell the computer to do what you want it to do.
That's exactly what I did. It wouldn't tell the reason.
All right. Well, that is actually, I think the last homework assignment, the one that was due at 10 o'clock today, that one resembles, actual, software or program development more realistically than the other homework assignments, much more so because, there's a lot of degree of freedom, right? Each subroutine, there are many ways to write it. The generate subroutine, there are many ways to write it as well. But once you understand how it is done, if I were to ask you to do it again, it would take you this much time to do it. Because now that you understand the concept, just doing it again is like going to be easy, and your solution will be a better solution too. I bet you can find things that you did, in your current program, the one that you turn in and go like, well, I could have done it slightly differently, now that I know da-da-da-da-da. Well, that's good, because that means you have learned from the experience of working on the homework assignment. That is studying for this class. Okay, that's really, when you're studying for this class, you're not actually studying a book just by reading the book. You're actually, trying to get something done. In the process, you're reading the pages and using Wikipedia and Google, okay, to try to make everything connect. All right, so what we'll do today, the main focus of today is the practice final. There are several links here. I'm going to start with the last one, because this one is the actual final. It includes the actual final from last year. So what I'll do is I'm going to download this. It is just a tar file, kind of like your homework assignments. So if you're doing this in Windows, it may not work very well because Windows does not like tar files. But if you do it in Linux, if you have your virtual machine up and running, you can actually put it onto your virtual machine. Then you can actually see the final exam questions. So I'll just go ahead and untar the final exam files. And we'll go through the actual part first. Okay, these are the actual questions that I asked in the exam from last semester. So this is from fall 2014, which is last semester. I'll just be using a text editor because the questions are integrated into the questions. So the first part is really just your first name, last name, and student ID. Okay, not much about that one. Q1.cpp. This is the question. So you can see the first thing in the page or in this file is Q1, and then the question is in it. Okay, the question is described at the end of this file. Answer the following question. Run the program not on the computer and use your student ID as input. For instance, if my ID was 1217204, then you press the enter key. The \n is the line feed character because in Linux we use a single line feed character to mark the end of a line. Write the output of the program in the following space. the number of lines provided may not be all needed. In other words, the number of lines that I give you does not indicate how many lines you will actually need. Usually it is more than what you need, but sometimes it may not even be that. Okay, so once again, it's not really that different from the other homework, the other exam questions, which is basically asking you to read the program and figure out what it does. This one we haven't really talked about, in terms of get line. So I'll just go ahead and explain what get line is. Okay, get line allows you to get an entire line of text from the standard input file, and it has 3 parameters. The first parameter is telling the computer where do you want to put the content, and where we want to put the content is line, which is a local variable with 81 characters reserved. The second parameter is how much space is there. Okay, the first one is basically telling it where you can start. The second one tells it how many bytes can I read, and in this case I can read up to 81 bytes because the size of line is 81 bytes. And the third parameter is what am I using as end of line. So in this case, because I'm using a Linux type environment, I'm using \n, which is a line feed character to mark the end of a line. Are there any questions about line 31, which is the one thing that we did not actually talk about in this class? No questions? Okay. So the key is the process. Okay, the key is actually process, which is taking the 2 parameters. The first one is line. Line, once again, is an array of characters. And the second one is the size of line, which is the number of characters of that array. So everything, all the really important stuff is done in process. And process is right here. And I'm trying to resize the screen so that everybody can read it, including people all the way to the back. Come on. Okay, I think it's easier to drag it here. There we go. All right. Okay, so this is process. Let me see if I can scroll it so that we can see the entire subroutine. There we go. So we can actually see the entire process. We know that buffer is basically the beginning of what we just entered on the line, and n is the number of characters. But in this case, it's the number of characters actually read. So if you type in a 7-digit student ID plus the line feed character, n would actually be without the line feed character, which is just the 7 digits. Are there any questions? Yep, go ahead.
Even though we're passing in an array of a size 81, it's only going to return the number of things that we're actually reading.
Well, we are passing 81 in here. Okay, so n is 81. But the way the code works is it will stop when we see the null character. Okay. All right. Let's take a look at the code now. Okay. We have 2 local variables. The first local variable is I. The second local variable is result. I doesn't really do a whole lot. Okay. So when you analyze a loop, what you need to do is to figure out, okay, what are we initializing before the loop? Result is initialized to 0. I is initialized to 0. These are things done before we get into the loop. The second thing and the most important part of a loop is how am I staying in the loop? This is the entire condition of staying in the loop. It is a conjunction, okay? It's a conjunction of 3 things. The first thing is what I'm looking into in buffer cannot be a null character. Okay? Why do you think 0 as a character, why do you think it is special? Remember C string? We talk about C string. What is the significance of 0 in the C string? It's a null terminator, right? So when we get to a 0, we basically says, okay, that's the end of the entire thing. So this loop, when this condition is false, okay, what can make this condition false? Buffer bracket I does not equal to 0. What can make it false? It equals to 0. It is 0. Okay, so that means when I scan through buffer and I get to the null terminator, it's time to get out of the loop. Okay, so this is one reason to get out of the loop. What is the other reason to get out of the loop? Well, it is not at I, but I plus 1. Okay, so I'm checking two positions in buffer, both at position I, index I, and index I plus 1. If either character is a null character, I get out of the loop. So that's also a third reason to get out of the loop. This one is also important from the perspective of reliable programming, and also security, because I'm getting out of the loop as soon as I plus 1 is no longer less than n, which means it is greater than or equal to n. In other words, I am not going to scan this array past the end of the entire array, even if I cannot find the null terminator. Now that is important because a lot of problems happens when people do not do bound checking like that. Okay, so this is bound checking. What am I doing with I? Well, the only thing I do with I, besides using it as an index, the only change I do to I in this loop is plus plus I as a post operation. If you look into the body of this loop from line 13 all the way down to line 22, I'm using I, but I'm not changing I. Okay, so this is so I is only changed per iteration by incrementing by 1. So just by looking at this line, which is line 11, we kind of have a pretty good idea of what we are, how we initialize the variable I in particular, and also how we stay in the loop, and what we do per iteration as far as I is concerned. So you can kind of basically say, okay, I goes from 0 to 1, 1 to 2, 2 to 3, and so on. By the time we get to either the null terminator, or by the time we get to the end of the buffer, then we exit the loop. Are there any questions about this? No questions? Okay. All right, so the next one is this line here. We talked about the cout variable, which is an output stream. What does this do? What does it print? We know cout is about printing, okay? It's sending something to the standard output file. In this case, what is it sending to the standard output file? What is buffer? Buffer is a character array, which is also a string. So it is sending the string to the standard output file. What is this part here? What does that mean?
9 feet.
Sorry?
9 feet.
9 feet or end of line. Okay, so whatever it takes to indicate the end of line, that's basically what it is. So at the beginning of each iteration, I print the entire buffer to the standard output file. And then the next thing I do is I am checking to see if buffer I, bracket I, is greater than buffer bracket I plus 1. What am I comparing? What is the type of buffer bracket I, and what is the type of buffer bracket I plus 1? Those are, well, it is an array of characters. I'm comparing characters. In other words, I'm comparing the ASCII code of characters in this case. If buffer bracket I is greater than buffer bracket I plus 1, which means the first character is greater than the second character, I am going to go through this sequence here. And can someone tell me quickly what this sequence is actually doing? This is it's swapping, exactly. It is exchanging the two characters to make them to be in order again. And then I increment result. Okay, so every time I do one exchange, I would increment result. Is that okay so far? And then I'm going to return the actual result at the end. All right. So now that we kind of know what this code is actually doing, let's go ahead and run it, but not using a program. Okay, we'll run it using just a piece of paper, or since I'm doing it on the projector, I use a text editor. Okay, to basically mean I'm not even going to run it on a particular computer using GCC to compile the program and stuff like that. So we'll go ahead and use just a plain text editor to run this program, and we'll go ahead and say, what if the input is 1217 7? What was the example that I used? 204. Okay, there we go. 204. Okay, so that's the input, and we want to run this algorithm through it. I is initialized to 0, so the first two characters that I'll be considering will be which two? The 1 and the 2, right? So the first line of the output is 1217204, because when I get to line 13, which is printing the entire string out, I have not done a single thing yet, okay? So whatever the input was is exactly the same thing that I'm going to printing out. So that's the first line of output. And then we do the comparison on line 14. On line 14, I'm comparing buffer bracket 0 and buffer bracket I plus 1, which is buffer bracket 1. Which two characters are we talking about in this particular student ID? The 1 and the 2, right? The first two characters. Do you think the ASCII, not knowing the exact ASCII code, do you think the ASCII code of 1 is greater than the ASCII code of 2? No. So the condition of the conditional statement is false. There is no else in this case. So we get to the end of the entire subroot, the entire loop. I gets incremented by 1, and then we go back to the beginning again. So now is the second one. Okay, so I'm just going to indicate this is the output. So in the second iteration, the first thing we do is we output the string first, right? Did we make any changes? We haven't done any changes yet. So 1217204 is going to be printed out, but this time, which two characters will I be comparing? The 2 and the 1, okay? The ASCII code of 2 is greater than the ASCII code of 1, so I'll be exchanging those two. As a result, these two will now be exchanged, but I do not print anything at this point, okay? So even though I know these two are now exchanged, I cannot say anything. Now, when you are tracing this, you can, on the side of your paper, you can use scratch area and just basically say, okay, now it is actually updated to 1127204. Okay, so this is not a part of the output. Do not put it into the output area, because I don't want to mistakenly use that and say, oh, that's your output. That is not the output, not yet. Okay. So you can basically say buffer, has this value at this point, but do not indicate it as a part of the output. And also as a result is now what? 1, because it was 0 to begin with. At the end of the conditional statement on line 21, we are adding 1 to result every single time we get into the then branch of the conditional statement. So now we go to the, is it time to exit the loop yet? Nope, okay. So now we get to the third iteration of the loop. In the third iteration of the loop, I has a value of what? 2, okay. So you can track that as well if you want to. So you can say in the first iteration, I has a value of 0. In the second iteration, I has a value of 1. This is the third iteration, I has a value of 2. So I has a value of 2. I should put this in here. There we go. Okay, so this is just one way to do it. Okay, how you want to keep track of the variables is entirely up to you. This is the third iteration, and it will output the string as it is right now, which is 1127204, and then it will go to the conditional statement, which is on line 14. Because I is 2, we'll be looking at buffer bracket 2 and buffer bracket 3. 2 is not greater than 7, so there's actually nothing to be done in this iteration. I gets incremented to 3, and now we are getting into the fourth iteration. In the fourth iteration, it will still output the string as it is first, and then it will do the comparison. This time we are looking at the 7 and the second 2. 7 as an ASCII code is greater than the ASCII code of 2, so we will go through the exchange. In this case, buffer will now become 1122704, and the result will be incremented to 2 in this case. And now we can go back and check the condition. I is incremented to 4. Is it time to exit the loop? No. It's not time to exit the loop because all the conditions are still true. Buffer bracket 4 is not a null terminator. Buffer bracket I plus 1, which is 5, is not a null terminator. I is 4, 4 plus 1 is 5. 5 is still less than 81. So all three conditions are still true. The conjunction of these conditions will be true as well. So we are not quite exiting yet. The output is now 1122704. And now we have to do the comparison. Which two characters are we comparing? 7 and a 0, and we should do the exchange. So now the buffer will become 1122074, and the result is incremented by 1, so it is 3. I becomes 5. Is it time to exit yet?
And so wasn't buffer at I plus 1 equal to 0?
Sorry?
No. Is buffer at I plus 1 is 0 though, right?
Well, okay, I is 4, right?
Yeah.
Yeah.
4 plus 1 is 5.
Yeah.
But that 0, okay, so let's, okay, I think what you guys are talking about here. This is the value 0, not the ASCII code of 0. It doesn't have single quotes around it. Now, if you have single quotes around it, then we are referring to the ASCII code of 0. Without the quotes, we are actually looking at the ASCII code 0 itself, not the ASCII code of 0. Okay, are there any questions about this? Because this can be confusing. The bit pattern 00000000 in binary does not represent the digit 0. The digit 0 has a representation of 30 in hexadecimal or 00110000. So you have to be sure that you know how to differentiate between the digit 0 and the ASCII code of 0. Because the ASCII 0 is actually the null terminator. Questions? Well, when I go into GDB with this code, we'll definitely see that. Okay, so we'll definitely have a chance to see that too. Okay. But all I can say is not time to quit just yet. Okay, I is now 5. So when I is 5, we are now looking at buffer bracket 5. Buffer bracket 5 is the 7 here. Buffer bracket 6 is the 4 here. Okay, so it's not time to quit yet. And also 5 is less than 81, so we have true, true, and true for the condition of this for loop. It's not time to exit yet, so now we have to move on and output the string as it is at this point. It is 1122074, and should we swap this time? In other words, we are looking at the 7 and the 4. Are we going to exchange those two characters? Yep. Okay, so we'll go ahead and exchange those. So buffer will now become 1122047, and result is going to become 4 because we are adding 1 every single time we get into the then branch of the conditional statement. I is incremented to 6. This is time to quit. Okay, when I becomes 6, it is time to stop because we'll be looking at this character and say, is that the null terminator? No, it is not. Okay, fine. What about the one next to it? Okay, it is. Okay, because so it's time to quit because what happens is this condition becomes false. When you have a conjunction, you need only one condition to be false in order to get out of the loop. Yep.
So in this case, because the array is of integer char type, each value doesn't have. We're looking at the ASCII code, right?
We are looking at each character. We're comparing the characters, right? But a character is nothing more than an 8-bit integer that stores the ASCII code, that is intended to store the ASCII code of characters.
So that's why when we got to 0, it actually didn't terminate. We were
The
actually-
digit 0,
Yeah, the digit 0, which
Right.
has its own ASCII code.
which has an ASCII code of 48 in decimal.
Yeah. So that's why it didn't quit when it got
That
there?
is correct.
All right.
Yep. All right. So now it is actually time to exit. So by the time we exit the loop, buffer has a content of 1122047. Result has a value of 4. Now that is important because when you go back to the main subroutine, it will actually ask you to say, okay, what is the buffer? Okay, because buffer is the name of the parameter, but what we use to specify that parameter is line, which is my local variable in main. So line at this point still has the value of 1122.047. So the output is once again 1122.07047, and the result. So the other line of the output is process returns, and the value that we are returning from process is 4 because that is the return value of the subroutine. So if you look at all the lines that has output colon, as the first part of the line, that is the actual output of this program. Or so I think. If you're like me and have no confidence in my ability to predict what a program is supposed to do, well, it's time to type in the program and compile it and let it run. So, are you guys ready to do that? Okay. And I think it's pre-compiled already. So last time I did this. Yep, Q1 is an executable already, so I can just go ahead and run it. And use 1217, what was it again? I cannot remember the 204. Yeah, 1217.204, press the enter key. That is the actual output of the program, and we'll see whether it matches what I think it should be. So the first line of the output is 1217.204. Second line is the same, 1217.204. Third line is still the same, this is one. I missed one line. Oh, okay, never mind. This is actually what I typed, so that's not a part of the output. This is the first line of the output. And that matches the first line of the output here. This is the second line of the output. It matches this output here. This is the third line of the output, 1127.204. It matches 1127.204 here. This is the fourth line of the output. It is 1127.204. Fifth line is 1122.704, which is matched here. Fourth line, the second last line is 1122.074, which is here. The last line is 1122.047, which is here. And then the very last line reports, what the subroutine is returning, and is supposed to return the value of 4. It is also here. So the way I dry ran this program was actually correct. Are there any questions about this particular question? Number 1. You have full access to these files now. They're all on Moodle. Okay. So if you want to have some practice, I would suggest to, punch in your own student ID or make up some, other student ID just to see what it does. Yep.
When you print out the whole array of characters,
It's null terminated. It will only print the array up to the null terminator.
Oh, so that was the cisp360 that we talked about.
Correct.
So it's different from when we do the printf of the other array of.
No, printf would do the same thing. If you use printf and a %s, it would also print only up to the null terminator. Up to, but excluding the null terminator.
But why do you usually use the for loop to print out the whole array of integers?
Because it's an array of integers, it is not an array of characters. Now, an array of characters can be seen as an array of really short integers, but at the same time, a char has a special meaning, which is it's basically saying it can also store the ASCII code of characters. So when you have an array of characters, you can also look at it as just a regular C string, which is null terminated. But you can also look at it as just a regular integer, an array of 8-bit integers, if that is what you want to do. Okay. Are there any other questions about question number 1? Yes.
Can you go back to
The source code.
Yeah. What did the in the main? What did the CEN dot getLine part? I understand getLine is getLine a subroutine?
It is called a method. It is kind of like a subroutine, but it's a subroutine of CN as an input stream.
Okay.
So what it does is it will read in an entire line at a time, and you specify the three parameters. The first parameter specifies where you're reading it into, the memory location that will store the content. The second one is indicating up to how many characters should I be reading. And in this case, because the buffer has 81 characters, I say, hey, you can read up to 81 characters, but we're not even coming close because a student ID only has 7 characters. And then the last parameter, which is quote \n quote, that's specifying what it should be using as the end of line character, and this is the convention of all Linux Unix system, which is the line feed character.
So where are you actually feeding in your ID number?
The ID number?
Yeah,
I typed it in on keyboard. So that is coming in from standard input file. Okay. Any other questions about this program? No other questions? Okay. So one thing you can do if you want to kind of play with this one a little bit is to change this greater than so it becomes less than. Okay, and then figure out what this program is supposed to do. Now, because this program does compile, you can dry run it first, okay, on a piece of paper, predict what is going to be the output of this program, and then you'll actually compile the program and run it to verify that your answer is actually correct. So there are things you can do with this program to kind of make it, to test, to make it a different question and test your knowledge of, running programs like this. Okay, so if there are no other questions about number 1, we're going to move on to number 2. Okay, so this is question number 2, and the question is always at the end. So run this program. That's again not on the computer. Make the input your student ID. So this is the common theme of all of these questions. What is the output of this program? You may or may not need all of the following lines. So the format of the question is the same as the first one, but the nature of this program is different. So we start with the main program again, and you can see that in this case we have 2 buffers. We have buffer A, which has 81 characters. We have buffer B, which also has 81 characters. They are 2 different arrays of characters. When we read, we're only reading into buffer A, okay? But you can see that this line, on line 29, it is almost the same thing as the get line of the other program. It only serves the one purpose of reading the input from standard input file. That's all it's doing. So the magic is now at buffer A. Do something. Do something is a subroutine, and the subroutine is up here. So the question is, what is this subroutine doing? Okay. Well, let's take a quick look at this subroutine and look at the structure of the code at least, and see if we can figure out what this subroutine is doing in general. Okay. And once we figure out what it's doing in general, then we'll go ahead and actually dry run it to see if we can figure out what the program is going to output as we run this algorithm. Line 7 is the beginning of a conditional statement. So is line 9 and line 11. But these 3 conditional statements are nested, one within the other one. Well, what that really means is in order to get here to do some actual processing, to get some actual work done, I need all 3 conditions to be true. P1 is an array of characters. A pointer to a character can be seen as an array of characters. Okay, is that part okay? We have seen it in the homework assignment. Hidden, okay, is one of those, right? So we have been using this convention since the first mastermind homework assignment. Score makes use of this particular feature in C program. So this is basically just checking, is the first character a null terminator? No. Okay, let's move on to the next one. Is the second character of P1 a null terminator? No, it's not. Well, now we can compare. Let's go ahead and compare the first character versus the second character. If the first character is greater than the second character, hey, we're going to do the same thing here. Exchange them, okay? And after we exchange, then we'll go ahead and print P1 to the standard output file, okay? Instead of printing the entire buffer, I'm printing P1. And then we'll do something with this thing here. So we'll do the recursion. Okay, so now the big question is, what is this thing doing? Okay, what is that expression actually, you're specifying? Well, once again, you look at this whole thing, and then you have to decode it one step at a time. Okay, don't look at this whole thing and say, oh, we have not seen something like this before. In reality, we have seen something like this before. It's actually in the notes. But assuming that we have not, okay, we have seen these things individually. So we just have to kind of combine those concepts and say, okay, this is how we stack up the Lego pieces, okay? What does this thing do as a stack of Lego pieces? We start from the innermost portion. How do we call this operator? The square brackets has a name. It's the indexing operator, okay? What is the purpose of the square brackets? It allows us to do something with an array. What is it?
Access the elements.
Exactly. It allows us to specify a single element out of an array. Right? Okay, so which element are we talking about? The second element. Okay? So now we are talking about the second element of P1 as an array. Is that part okay? It should be okay, because we have been using P1 bracket 1, before already, right? So now we're taking the address of that particular character. Well, we can take the address of anything that can store something. The second element of an array, does it have a position or a place in memory to store something? If you can change the value of that location, it has a location. So anything that has a location, you can say, I want to know the address of that thing. I don't care about the value of that thing. I want to know the address of that thing. So we can take the address of that thing. And then what we do with that is to use the address of the second element of P1, and pass it as a parameter to, guess what? Do something. And we'll keep doing this until what? It seems like we have a quote-unquote loop here, but it's not actually a loop. It is called recursion, but it has to stop at some point. I wouldn't give you guys something that would not stop, and you guys keep going like, oh, this is not stopping.
Okay, it'll stop when
It will stop
P1.
when
Q1 1 equals 0.
it will stop when
Either first two functional statements or false.
exactly. So if the first condition is false, we do not do the recursion. If the second condition is false, we also do not do the recursion. The third one is, regardless of true, false, we do the recursion. Let's do the recursion because the recursion, which is on line 19, is not a part of the third conditional statement. It is after the third conditional statement. So whether the condition of the third conditional statement is true or not does not impact whether I perform another recursion or not. Okay. So now the question is, will this eventually be true? Will eventually become false? It seems like this is bad. We're looking at the same character over and over again. If it is not null to begin with, how can it possibly become null? But we are not looking at the same character. Every time you call the subroutine, the parameter is changed. Now let's think about this a little bit. P1, okay, from the perspective of any particular invocation of do something, okay, P1 is what I got, okay? Somebody told me, hey, Tech, this is an array, this is the beginning of the entire array, I want you to do the following, da 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 da, okay? So I go through the whole process. So I would look at the beginning of the array and say, is that a no terminator? No. I look at the second character, is it a no terminator? No. And I will do this, depending on whether the first one is greater than the second one. I might do the exchange, I might not, okay? But at the time I get to line 19, what am I doing? I'm saying, hey, this is my entire array. I'm going to specify the second item, the address of the second item, as the beginning to the next invocation. So from the second invocation's perspective, the beginning of the array is actually the second character of my array. Is that making any sense? So if each invocation is moving on by one position, eventually it will get to the end. Is that okay so far?
So the second time it goes through, it would check the third spot.
The second time, it will check the second character and the third character.
Oh, I mean the second time we get the recursive statement.
That will be the third invocation. Yeah, in the third invocation, it'll be checking the third and the fourth characters. But at some point, it's going to get to the null character, right? Because we know a student ID only has 7 digits. So that means the 8th character of the entire array has to be a null terminator. The recursion has to stop at that point, because at that point, P1 bracket 1 will become a null character, and as a result, the recursion will stop. Is that okay? Sort of? Yep.
So how do we know that the first two conditional statements are checking for a null terminator rather than just a value 0 in your student?
Because that 0 does not have quotes around it.
So if it did have quotes, then it would be checking for that value?
It will be checking for the ASCII code of 0.
Okay.
The single quotes basically specifies, give me the ASCII code of whatever is in between the quotes. Without the quotes, it's literally the value 0, not the ASCII of digit 0.
Right, I'm going to do an ASCII code.
Yes.
So if we did have double quotes on that, if our our ID did have a 0 in it, that would be considered a null terminator?
That would make it stop.
Yeah.
Yep. But since it does not have the single quotes, we are looking for the null terminator in this case. All right. So now that we know this, this code is doing something like that, it's kind of like the first question, except this one is doing it recursively. Okay, it's kind of doing the same thing, but it's recursive. So the question is, how do you track this? On a piece of paper, because you're not running it on the computer, so you are responsible to keep track of all of these things. How many invocations are we talking about? And for each invocation, what is P1 referring to? Well, that part is up to you, okay? Because I talked about how to track programs like this in cisp300. When I taught cisp300, I have a particular way of doing it. But this class is not cisp300, and as a result, you have to devise your own way of keeping track of things like this. I can give you a few recommendations, like if I were to do this particular question, this is what I would do. Okay. All right. So now that we kind of know what this is doing, let's go ahead and see if I can track this manually and figure out what it is going to do. I'm going to skip the main function because we kind of know what it does already. So we'll go ahead and start with, well, I still need an ID here. So we'll say P1 is the string. Now when we refer to a string in C and C++, we use double quotes. So we specify, I'm just using the example here, 1205, 1205821. Okay, here we go. And now we are back to the first invocation. Go. All right. So the way I would do this is to say, I would differentiate. The most important part is to understand that you have to differentiate one invocation from another. We only have one subroutine. Do something is a single subroutine, but we have multiple versions of the same subroutine activated at some time. So you have to be able to differentiate between the invocations of the same subroutine. So I would say, okay, do something, and maybe use a :1 to indicate this is the first invocation. So in the first invocation, P1 does point to the original beginning point of the entire buffer, which is, so that's why the string is indicating 1205821. Is that okay? All right. And then we can go ahead and trace the program. When we trace the program, we have line 7. Line 7 is true. Line 9 is true. Line 11 is true. Whoops, I take it back. Line 11 is not true. The condition of line 11 is not true because we are comparing the first character versus the second one. And if you look at this code here, the first is a 1, the second one is a 2. 1 is not greater than 2, so we are not going to do any exchange. So when we get to line 18, we actually do the output. So when we do the output, the string is still like this, right? So we'll say the output is simply 1205821. Not a problem. Now what do? We're calling the subroutine again. Okay, so when we call the subroutine again, I will do something like this. I will say do something. This is the second invocation. I keep track of the invocations, the first, the second, and so on. In the second invocation, what would be P1 as a string? Yep, because it is starting with the second character. So as a string which is null terminated, it becomes 0205821. The first character is not a part of the string anymore when we are looking at the second invocation of the subroutine. Are there any questions about this? Because this is really, really important. Okay, when you want to keep track of the execution of a subroutine, when it is recursive, you have to do something like this. Okay, and if we look at the first character, it is a 2. We look at the second character, it is the digit 0, not ASCII 0. So the first condition is true, the second condition is true, the third condition is true as well because the ASCII code of 2 is greater than the ASCII code of 0. So as a result, we'll do the exchange, okay? So we'll do the exchange and update the string to become 025821. So by the time we get to the line 18, which is printing the string out as a null terminated string, we'll be outputting 025821, okay? And then we will get to line 18 and perform the recursion again. So this time we'll be calling do something, but the way I remember this is not only to remember that this is do something, but this is the third invocation of do something. And you can see how I use indentation to help visualize, okay, which invocation are we talking about? We are deepening, the invocations. And P1 as a parameter to the third invocation would be what? It starts with the second character of the previous invocation. It'll be 25821, right? And we go to the first character is 2, the second character is 5. Neither is the null terminator, so the condition of line 7 and line 9 are both true. We get to line 11. The ASCII code of 2 is not greater than the ASCII code of 5. There's no exchange to do. We get to line 18. So by the time we get to line 18, the output is just whatever P1 is, which is 25821. At this point, I'm going to stop just a little bit. I'm just going to pause and say, but how many P1s are there actually out there? There are 3. Okay? You can only see the last one. You can only see the most recent one, P1, but the other 2 are actually somewhere in the computer. Okay? It's just that you do not have any visibility. As the third invocation, you only have visibility of P1 of the third invocation. But the other 2 is actually there somewhere. Okay. All right, so now that we have done the output, we get to line 19. Line 19 is going to do something again. At this time, we're dealing with the fourth invocation. So do something, :4. P1, in this case, is going to start with a 5, so 5821. And we look at the line 7, line 9, they're both true. Line 11 is false. There's nothing to exchange. We get to line 18. So the output at this point is going to be 5821. And then we do the recursion again. This is our 5th invocation. At this time, P1 will be 821. We look at the first condition, it is true. We look at the second condition, it is true. We look at the third condition, it is true as well. So we have to exchange the characters. So 821 becomes 281. So by the time we get to the print or the cout statement, it is 281. And then we have to perform another invocation. Do something. This is the 6th invocation. And at that time, P1 is going to be just 21. Whoops, excuse me. I forgot to look at the updated version of the array. Okay, so don't make that mistake. Okay, it is 81 as the 6th invocation. So the whoops, not outputting yet. The first condition is, okay, I think we can do this. Okay, so this is, there we go, that's better. So we look at the first condition. It is true because 8 is not the null character. 1 is not the null character. This is also true because the ASCII code of 8 is greater than the ASCII code of 1. So we have to do the exchange. When we do the exchange, we just go ahead and say 8-1 becomes 1-8, okay? And then we do the output here, okay, the C out. So by the time we get to C out, it will become 1-8 already. And then we do the recursion one more time. Something, 7. And then this time P1 will be what? Just 8. Yep. And this time, when we perform this comparison, would that be true or false? That will still be true because 8 is not a null character. What about the character next to 8? It has to be the null character because that is the end. 8 is the last character of a null terminated string, which means the character next to 8 is the null character. So this condition on line 9 is false. If that is false, I'm not going to go through the rest of the conditional statement. I'm going to exit right away and I'll return to the previous invocation. So when I get back to the previous invocation, is there anything for me to do in the previous invocation? In other words, when I go from do something 7 back to do something 6, where am I exactly going back to? Which line am I going back to? I'm trying to continue from not line 19 exactly, from right after line 19. Okay, because if I go back to line 19, I'll be doing something over and over again. Is there anything else to do after line 19 in this entire subroutine? Absolutely nothing, except to return, right? So when I return from invocation 6, I go back to invocation 5. Is there anything to do in invocation 5? Nothing. So I return to do something. Invocation 4, nothing to do. Now this seems kind of silly because there's nothing to do, but if I change the program just slightly, it won't be silly anymore. Okay, and there's nothing to do here, and the whole thing will just return to main, and I'm done. So the actual output in this case should be the way it is indicated here. So it should be 1205821, 025821, 25821, 5821, 281, and 18. So far, and then main does not do any more printing. I think. Oh, it does. Okay. Okay. This is the big question. What is main going to do when it prints buffer again? When it prints buffer A again on line 31? So this is the big question. Did we actually change buffer 1? We did. Okay, because when you pass an array or a pointer to a subroutine, the subroutine knows how to mess around with your stuff because you gave it the address to mess around with your stuff. So buffer A is in fact changed. So the question now is, how is it changed? Can we look at how we update P1 to figure out how buffer A is actually changed? Well, it is not easy because you kind of have to align everything in a way to do it. So I'm going to realign everything so they all line up correctly. So let me just want to do it in a certain way so that everything is lined up correctly. That's good. Can you guys see what I'm trying to do here to line up? I'm lining everything up so that the last character is lined up on the same column. So this character, which is the last position, is all lined up. Okay? So how do we read this whole thing here? Let me see if I can move the screen a little bit. Okay, there we go. And move this up. So what do you think line 31 of main is going to print? Did I do anything with the first character? The first character was here. Did I do something with it? I didn't do a single thing with it, so the one would still be there. I don't have a place to write it anymore, so I'm going to have to start up another mousepad for this purpose. So let's go to accessories, mousepad, because I need to keep track of this. Okay. So we have the one. The one is not changed at all. It is still the first character. Did we do something to the second character? We did. There we go. We did something to the second character. So after we exchanged the second and the third character, that was the last change to the second position. So the second one would still be a 0. did we do something to the third character? We did something to the third character over here by exchanging it with the second one. Did we do anything after that to the third character? Nope, not that I can see it. Okay, so the third character will still be a 2. What about the fourth character, the 5? 5, 5, 5, 5, 5. We did not do a single thing with the fifth character, the fourth character, so the 5 will still be here. What about the 8? Okay, we did do something to the 8. The last update changed the fifth character from an 8 to a 2, so that will become a 2 here. What about the sixth character? It started off as a 2, but eventually it became a 1. What about the last character? It started off as a 1, eventually it got updated to an 8. So this is the actual output. The final output from main is going to print this out. Is that okay so far? So this means, when you're tracking something like this, you have to make sure that, you align everything, because we are still looking at the same position. In other words, this one here is the same position as this one here, which is the same as this 8 here. Whenever we do something, you have to use the last updated value as the actual value. Are there any questions about this part? No questions? Okay. Let's run it first at full speed, okay, just to verify the output is correct. And then we'll go into GDB and I'll show you some tools that can help you really understand what is going on with this program. Okay? And we just run Q2 and we'll feed it the same test case in this case, which is 1205821. Press the enter key and then we'll check the output. So we claim the output should be 1205821 as the first one, which is this line here, so that's good. The second line should print 025821, 025821. The third line should be 25821, 25821. The fourth line is 5821, 5821, 281, 281, 18 is 18 here. And then the final output line, which is from main, is not coming from do something, is 1025218, 1025218. So the dry run of this particular algorithm is actually correct. Okay. Now I'm going to use GDB to help you, kind of get a better understanding of everything. So I'm going to G++ recompile the program because I don't remember whether I used the -G to compile it last time, so we'll do it again. And then we'll do a GDB Q2. Like this. Put a breakpoint at the entry point of do something. Run the program and specify the string that we have been using, which is 1205821. Copy and paste it. There we go. All right. So from GDB, you can tell right away that this is the input to the first invocation. And when you single step, it will clearly indicate that the first 2 conditions are true, the third one is not, and it will just do the output here. And it will do the recursion, okay? Nothing too surprising. The first invocation is pretty easy. This is the second invocation. You can see that P1 has a certain address, and it's as a string, as a null-terminated C string, it is now having the content of 2085821. Okay, the question now is, how does P1 of the second invocation relate to P1 of the first invocation? Can someone tell me how they are different? We can tell they're different, but how are they different? Is it how you think they should be different? Okay, let's take a look. I mean, they're on the screen already. The P1 parameter of the first invocation ends with 92F as a number, as a hexadecimal number. The one of the second invocation ends with 930 in hexadecimal. What is the difference between 92F and 930? We never talked about hexadecimal numbers, so we have no idea how to do this, right?
Yeah, added to one.
Yep, exactly. They're off by 1 because F is the last digit in hexadecimal and 0 is the one that roll over. Does that make sense that this is 1 more than the one before? Okay? But that means, the first character of P1 of the second invocation is actually the very same thing as the second character of P1 of the first invocation. Does that make any sense? Now this is why I said, use GDB, because it does give you extra information that is difficult for me to convey, by using a piece of paper to trace it. But when you go through GDB, the concept should be a lot easier to understand. So I'm just going to do the continue here until we get to the last one, which is this one here. So by the time we get here, remember BT, backtrace, we talked about this command in GDB as well. Because how do we know that we actually have 6 invocations, kind of all stacked up at this point? Well, backtrace will show you. This is what backtrace does. Backtrace says, invocations relative to where I am right now. Okay, 0 is where I am. Ground 0 is 8-1. P1 is 8-1. The invocation prior to this, which is number 1, pound 1. Is P1 is 281, and so on. So this is a really good tool to really help you understand what is going on here. And you can also see that pound 5, which is the very first invocation, the string has changed already because the first character, the second last, which is the 6th character of the first invocation, is the 5th character of the second invocation. It is the 4th character of the 3rd invocation, and so on. They are really the same thing. It is the very same character. It's just, when you look at it from a different perspective, it is here, 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 and so on. So this is a tool to help you understand, recursion and how subroutines are done in C and C++. Are there any questions about this trace? Because I really, really want you guys to get this down. Yep, go ahead.
So I guess you could have put like a statement at the end that said like, if you're in a certain invocation, do something, right? Could you do something like that? That would, because then you wouldn't go through and it wouldn't do anything as you went back through them, but maybe at one.
But if I change the program just slightly, it will do that. Okay, so let me get out of the GDB because I think in GDB this is all I wanted to demonstrate. This is all I wanted to show you. Okay, if I go back to Q2, all I need to do is to exchange do something with another line. That will change the whole thing, because now there is something to do after we come back, because the printing of the string is after we do the recursion. So now it will display something that is different from the first time, because the one that we had before is printing the string before the recursion. This one is doing the recursion before the printing. So the output is going to be very different, except for the very last thing that we did. But it's going to be completely different except for the very last output from main itself. But all the output from inside the subroutine will be different. So I'm not going to give you the solution to this one. I will leave it up to you guys to do it, okay? But I strongly recommend don't use a 7-digit student ID. This will work just fine with a 4-digit student ID, so you don't have to go through as many levels, okay? But it is important to understand how this variation of this program is going to do things differently compared to the first one, because the change is quote unquote subtle, right? Because I just exchanged 2 lines. But the output is going to be different. Okay, so I would do a dry run on this one first, and then actually run the program to see how it is different from the original program. Yep.
So originally, when you call to do something in the main function, you just put buffer and pay into it. But when you do it recursively, you put the ampersand, so the address of that second member. Is that because you just want that particular member to start it there?
Because as a recursive subroutine, I needed to stop at some point. And if I do it this way, it will stop at some point because I keep moving the parameter closer and closer to the null terminator. And at some point, it's going to be on top of the null terminator.
Okay. So
Okay.
is that why you want the address of the next member of that you pass that?
Because it still has more work to do, it needs the address to the rest of the string. Okay. Now the other thing we can also talk about in this one is the way I describe it. This would serve the same purpose. P1 plus 1 would have done the same thing. It's just, in C there are multiple ways to refer to the same thing. This will do exactly the same thing. We talked about pointer arithmetics. This is coming from the pointer arithmetic topic that we talked about. Okay. We have seen recursions where, when we come back from the recursion, there's more work to be done. Where did we encounter something like that? That should be pretty fresh in your memory right now. It's your homework assignment that was due today. Okay, so assuming you use the generate and test approach that we talked about in class, what do you have something to do after the recursion? Remember the generate and test code that we talked about in class? Where is that recursion? What kind of control structure is it in? I'll give you two choices. Is it in a conditional statement or is it in a loop? It's in a loop, right? So when you come back from a recursion, what else do you have to do? Not a single thing, right? Not a single thing, because there are multiple things to do. So you have to continue the loop of that particular invocation level, and potentially you have to do the recursion again because you did not find a valid candidate as your next guess. So that is also a good demonstration of why recursion is useful, because that gives you the ability to do that. Are there any other questions about number 2? Questions? All right. Let's take a look at number 3. And the question is down here. The question is, use the first 4 digits of your student ID as the input. What is the output of this program? Okay. So we look at this is one program. It doesn't even have any subroutine. Okay. Line 10 is, I'm hoping by now we understand what line 10 is doing. Is that okay? All it does is to read a line from standard input file, put it into PASSWD or password in this case as a character of array, as an array of characters, and then we do some processing with that array. Okay, so the actual processing is done here in this loop. Line 15 is just printing password out again, which is not the most crucial part. The most crucial part would be these 4 lines. Okay. Let's see. We have, let's take a look at I and how we stay in the loop and how we exit the loop. I starts with 0. We stay in the loop as long as password bracket I is not null. Okay, it's not a null character, and then ++ I as the post operation for each iteration. So all we are really doing is to say, hey, for each character in this particular C string, do the following stuff. Okay, that's all it's saying. So the real focus in this case is line 13. What is line 13 doing with each character in the string? Okay, it looks like a big, huge mess to me. I'm gonna give up. No, there's no need to to think this is really a big mess. We look at this one operator at a time. Okay, we start with the innermost part of the expression. That refers to the character, a particular character in the array. Okay. And what happens when you subtract the ASCII code of 0 from the ASCII code of one of the digits? You get the value of that digit, right? So if the digit is 7, you get the value of 7. If the digit is 2, you get a value of 2. If the digit is 0 itself, what do you think is the difference between the ASCII code of 0 and the ASCII code of 0? The difference is 0. Okay, so it should work out. Okay, so this part is really just for converting the ASCII code of a digit to the value represented by that digit. That's all this part is doing. Once we have that value, we're going to add I to it. I is really just the index or the position of that particular character, and then a constant of 5. Okay, so basic stuff, just addition. After we perform this entire sum, okay, we multiply it by 11, and then we multiply by 10. Holy smoly, I don't like division at all. Division by 10 just scares me, especially when I'm supposed to take the remainder of the division. Would that be a problem? No, exactly. So now we know exactly what we're doing. The big question is, what is the range of value of this part? I know the exact value depends on what is at password bracket I at the time, but what is the range of value of this part here? From 0 to 9, exactly. Because if it is mod 10, it can only get up to 9. If you divide the number by x, okay, the remainder can only be up to x minus 1. All right. So what am I actually doing by adding the ASCII code of 0 to a particular value from 0 to 9?
Making it the ASCII code of that value as a character?
Exactly. I'm recreating the ASCII code of that digit, of the digit corresponding to the value that we just computed. In other words, I'm just playing games with the digits so that I come up with a different digit. Okay? All right. Well, let's go ahead and give it a try. So if the actual input is 1270, let's figure out what the new number is going to be. So 1270, and let's take a look at the first one, okay? And what we'll do is we'll do this like this. Okay, here we go. So the ASCII code of 1 minus the ASCII code of 0 is going to be 1. What do we do with this 1? We use 1 and we add it to the index of this particular character, which is 0 at the time, and then plus the 5, which is the constant. That will give us 6. We use 6 to multiply that to 11. That will give us 66. And 66 mod 10, the most scary part of this calculation, is the remainder of 66 divided by 10, which is 6. Exactly. And then we use 6 and add it to the ASCII code of 0. That will give us the ASCII code of 6. That's it. So the first character is going to be 6 after the conversion. Yep.
If you're adding the ASCII code of 0, isn't that like 48?
It is 48 as the ASCII code, but when you look at it as a character, it is, yeah. When you look at it as a character, it is 6 as a character. All right, what about the second one? Well, about the same thing, with some minor differences. 2 minus the ASCII code of 2 minus the ASCII code of 0 is 2 as a value. So this is 2 here, but the index has changed, so I is now 1. 2 plus 1 plus 5 is 8. 8 times 11 is 88. 88 mod 10 is just 8. So the second character is now updated to a value of 8. The third one was 7 to begin with. 7 minus 0 is 7. Or the ASCII code of 7 minus the ASCII code of 0 is 7. 7 plus 2, because I is 2 at this time, that's 14. And 14 times 11 is 154. 154 mod 10 is just 4. So that should be a 4 here. The last one is a 0. So the ASCII code of 0 minus the ASCII code of 0 is the value of 0 itself. 0 is here. Index I is now 3. And that whole thing becomes 8. 8 times 11 is 88. And 88 mod 10 is 8. So the last digit is 8 as well. That's it. That's the output. Because line 15 is just taking these 4 characters and spit it back out. That's all it's going to do. Are there any questions about this particular program? I think, of the first and of all the questions so far, this one is the easiest. You know, you just have to don't make any real mistakes, you know, when you're doing the calculations. Is that okay? Well, I'm not going to trust myself with all this math here, so I'm going to run it. And 1270 was the input. The output is 6848, which seems different from what I have. Nope, no, it is the same. Okay, never mind. Any questions about number 3? Okay, let's move on to question number 4. And these are the actual questions from last semester. Q4.cpp. Oh, this one is cute. Write the code. Okay, so this one you have there's room for your creativity in this case. Okay, you're not just tracing bytecode, you actually can write it. Write the code in is sorted so that it returns a non-zero if and only if 1, all elements of odd indices up to the no terminator are digits, and 2, all elements of odd digits up to the no terminator are they're digits and odd digits. So this means, okay, this returns a 0 because they're not odd digits. The elements of odd indices are not digits, are not odd digits. Okay, there we go. This one returns a non-zero because all elements of odd indices up to the no terminator are digits. So we are looking at this guy, and this guy. They're all digits. And on top of that, they are all odd digits as well. 1, 3, and 5 are odd digits. This one returns a 0 because they're all zeros here, and 0 is not odd. This one returns a non-zero because 1, 3, 5 are all odd. This one returns a 0 because these are not even digits to begin with. This one returns a 0 because one of them is not a digit. F is not a digit. This one returns a 0 because one of them is not odd, because 4 is not odd. So you're supposed to write a subroutine to check these things and return a 0 or non-zero accordingly. I know the name of the subroutine is sorted is not really correct because it is supposed to be is doubly odd. That's the name of the subroutine, because I want odd digits at odd places. Okay. Any questions about this one? So this one does, have you have to write a code to do it. Okay, quick check here. Is this going to be a loop, or do you think it's going to be a conditional statement? It is a very tricky question, okay? This is a trick question, so go ahead and pick your answer. Or is there any other way to do it other than a loop or a conditional statement? You cannot hard code it because you don't know ahead of time how many digits I'm going to give you. So I can give you like 1 digit, I can give you 2 digits, I can give you 20 digits. So you have to be prepared for any number of digits in the string. Okay, so once again, I ask you the question: is it going to be a loop? Is it going to be a conditional statement? Or is it going to be something else? The answer is all of the above. You can do it as a loop. Okay, that would be the most. Most people would do it in the loop. You can do it with a conditional statement if you use recursion. You can also use a ternary operator combined with recursion. So you can avoid a loop and a conditional statement if you do it the third way. Okay? Are there any questions about these 3 different ways of doing this? The 3 quote-unquote control structures. Do you want me to show you the answer, or do you want to kind of try to figure it out? Okay, yes to which question? I can see you guys nodding, but you nodding to yes, give us the solution, or nodding to yes, please. I want the time to work on it first. You guys don't want time to work on it first. You want a spoiler. You wanted me to tell you the ending of episode 7 of Star Wars now. Okay, for those of you who don't want the solution, just plug your ears and shut your eyes. Okay, and somebody's going to pat your shoulder when it's all done. Nobody is requesting anything like that. Okay, fine. Okay, we'll do the first way first, which is done as a loop. Okay, so if you do it as a loop, you basically say result is true until it is proven false. Okay, so we basically say we're going to assume it is all good until we find a reason to say it is not the case. So when it is like that, then you say for int I equal to 0, so we start from index 0. Well, there are two ways to do it. I can start with index 1 to be, it doesn't really matter, start with 0. And then we say there's a condition to stay in the loop, and then for each iteration, instead of I++, I'm going to do I plus equal to 2, because I'm going to skip 0, 2, 4, 8, 4, 6, 8, and so on. Okay, so that means in order to stay in the loop, the first one is result still needs to be non-zero. Because the moment I find something contrary to what I need, I'm just going to get out of the loop and say, hey, return 0. Because one of the digits is, one of the places or one of the characters is not a digit, okay? Return a 0. Or one of the digits is not an odd digit, return a 0. So if I find any reason to return a 0, it's time to stop and say, okay, we'll just go ahead and return a 0. Otherwise, we have to move on and see if there are additional reasons to say, okay, let's return a 0. I also want to stop when I get to the end of the string. Now, this part gets a little bit tricky because the indexes are skipping, okay? They go from 0 to 2 to 4 and so on, right? So that means, I have to check two positions to check for the null character. I have to check at buffer bracket I to check for the null character, and I also have to go to bracket I plus 1 to check for the null character.
That's because you're skipping by 2?
Because I'm skipping by 2. Because I'm skipping characters 0, 2, 4. So if I do it this way, I would also be catching buffer bracket 1, buffer bracket 3, and the other ones. So I know I would exit at the right time. Is that okay so far?
But wouldn't that jump up by 1? Because if you say I was 0, then you're saying buffer of 0 and then buffer of 1. Oh,
I just need to catch the first null terminator. That's all I need to do.
okay.
And the way I test it here will catch the first one. There's no comparison. How can I do something like that without comparing it to 0?
It seems like it would, like if you were on the last character and like the last one was odd, then you would not enter the full loop because the next one is the null terminator. I feel like it should be I plus 2.
I plus 2 would be the one after that. So that would be I plus 1 and I plus 2 then. That would be I plus 1 and I plus 2. Okay. But what if you have a null string? If you have a null string, which means there's nothing in the string, this will not exit at all. So I think the original condition is actually correct. Well, I guess we'll, uh-oh, I just erased more than I need. I keep using the wrong key on the keyboard. I think we can redo. No, we cannot. Okay, that's fine. We'll just do it. First condition is result, and then we want buffer bracket I and buffer bracket I plus 1. All right, so the only thing I need to do here is to set result, okay? I have to be able to set result to 0 when it is appropriate to set result to 0. So to set result to 0, the first thing I have to do is to say, well, is it even a digit, okay? Because I want the result to be a 1 only if it is a digit, right? There is a call called isDigit, which I'm not going to use. So I'll just go ahead and do the long way of doing this. So if it is a digit, then buffer bracket I has to be greater than or equal to the ASCII code of 0, and buffer bracket I has to be less than or equal to the ASCII code of 9. So these two conditions will guarantee that it is a digit. Then I want to check if it is an odd digit, right? So on top of that, I want buffer divided by 2 has a remainder of 1. But that will be enough already. Because there are only two possible remainders from dividing by 2. You can have a remainder of 0, or you can have a remainder of 1. A remainder of 0 will make this false, right? Because any value of 0 is interpreted as false, and as a conjunction, if any part of this is false, the whole thing is false. And then after this, I just say return result. That's it. So this is, I think this is one way to implement is doubly odd. So we'll check it, we'll test it, okay? One of the questions, by the way, may come in the form of, oh, this is the program, this is what it's supposed to do, and I know it is faulty, okay? The program is not correct. Give me a test case that will expose the flaw of this program. That can be a part of the questions, okay? So what you do at this point is to look at this code, look at the behavior, expected behavior, and say, okay, how do we test to make sure that this program does work correctly? Oh, it doesn't like that. Invalid operands of, oh, okay, what did I do wrong here? I'm just gonna, I'm trying to mod 2 with an entire array, which is a pointer. You cannot do that. On the other hand, if it's a single character, which is a very short integer, yeah, we can do that. We can divide it by 2. There we go. All right, so how do we test it? What about a null string? In other words, what about a string that has nothing in it except for the null terminator all by itself? Should it return a 1 or should it return a 0? In other words, are all characters at odd indexes odd digits? Do we have any proof otherwise? Well, since we don't have any proof otherwise, it should return true. It is doubly odd. If no one is in the forest, right? It's that kind of argument. All right, so let's check this one. Should it return, if I press enter right now, should it return true or false?
False.
True. Because this is not at an odd index, so I have no evidence that something at an odd index does not meet the requirements.
Index of 0.
Yep, that's index of 0.
Okay.
What about this? That should not be doubly odd, right? Because the second 0 is clearly at an index of 1, which is odd, but yet the digit itself is not odd. It's not doubly odd. Very good. What about this guy here? Not doubly odd because A is not even a digit. What about this one? It is doubly odd because even though the first character is not a digit, who cares? I don't even pay attention to the characters at even indexes, but the one that at the odd index is actually odd. Uh-oh, it says the string is not doubly odd. Oh, Houston, we have a problem. Okay, now how do you debug it? Yep.
I think it is because you have +1.
Well, the only reason why it would say it's not doubly odd is I set result to 0. So that would be the focus, is why is result becoming 0 when it's not supposed to? Okay, so let's go ahead and look at the source code again, and I'll let you guys take a look and find out why it is not doing it correctly. Okay, so we're looking at the digit 1, right? Is the ASCII code of 1 greater than or equal to the ASCII code of 0? It is true.
We're looking at what input? We're looking at which input? The A1?
A1.
That's at index 0, so that'd be looking at the
We'll be looking at, oh, because I is, I forgot about that. Because we are looking at index 0, but we should be looking at index 1. So, now we're looking at the right character. Very good. Let's see. Keep the plus again. Okay, A1 is doubly odd again. Okay, very good. Well, let's check the all the previous test cases. 0 is doubly odd. Okay. 1 is doubly odd. And let's see. 0A is not. 0, 0 is not. 0, 1 is. 0, 1, 0A is not. 0, 1, 0, 3 is, and so on. So I think the program is working now. Good catch. Did you guys see what flaw I had put into the program to begin with? I forgot the +1 in the square brackets. All right.
So looking at the even indices.
Right, I was looking at the even indexes instead of the odd ones. Yep, exactly. All right. Well, we have 2 more questions to go. This is question number 5, and this one has a little bit of structure in it. Okay, if A, B, C, D, E, F is the input, what is the output of this program? And the way it works, okay, the first thing we want to look at is this part here. It is a structure definition. I'm hoping that most of you remember what a structure is. If you have been doing your homework assignment for the past, what, 2-3 weeks or so, you should know what a structure is. So what is the odd part of this particular structure definition? That looks like, hey, that should not be possible. This is like circular reasoning. PTR, right? Pointer, PTR, on line 8, is a pointer to a struct X. How is that possible if I'm still defining struct X? Well, let me ask you this question then. How big is a pointer? We're dealing, okay, a pointer has to store what? What does a pointer store? It stores an address of something, right? It can store the address of a character, the address of an integer, the address of a structure, okay? You know, those are the things that you have seen in your homework assignment. Is that okay? Do you think the size or the number of bytes that it takes for a address differs depending on what it is an address of? No, it's going to be the same, right? So if you're using a 32-bit machine, how big do you think is an address? How many bits do we need to store an address with a 32-bit machine? 32 bits. Well, how many bytes do you need to use? How many bytes do you need to store an address for a 64-bit system? 64 bits. Okay. All right. So that means the size of an address or the size of a pointer does not depending on what it is an address of. So that means this should not have a problem. Because as far as the compiler is concerned, it only needs to know, oh, V will take up 1 byte and PTR takes up 4 bytes. That's all it needs to know. And everything works out, right? PTR is something that takes up 4 bytes, it stores an address, and the address of PTR is the address of another struct X. Yep.
So you just said PTR has 4 bytes in it?
Yeah, PTR is going to use up 4 bytes.
But I thought you said at 32.
32 bits is 4 bytes.
Oh.
There are 8 bits to 1 byte. You have to thank the early computer scientists of using bits, bytes, and nibbles to refer to chunks of bits. So that would make a long word or a 32-bit thing to be a gulp, I suppose, instead of a byte. It's a big byte. Okay, so getting back to this one here, is everybody okay with this one? the PTR is a pointer to a struct X, even though we are still defining a struct X? Yes? I know? Okay. Well, if that is the case, we can just kind of go through this code and find out, what it does, okay? Are there any questions about this? It is an array of, A is an array of what? Struct X, okay, an array of structures. Okay, good. That's not too bad. I is an integer, and PTR as a local variable is a pointer to a struct X. All right. PTR is A. Is that okay? Are there any questions about this particular assignment statement?
Doesn't it need the asterisk?
Nope. Well, you can put an asterisk. It doesn't really matter because when you're dealing with an address, it is already the address of the entire thing. If we put an asterisk, ampersand here, it will work just fine as well. Okay. So we have a pointer which is now the address of the entire array, or you can also look at it as the address of the first element of the entire array. We have a loop here, and if you look at the structure of the loop, we have I initialized to 0. I is less than array size minus 1 is the condition, and then plus I is the post operation. So we are basically saying go through every single element of the array except for the last one, okay? And what we do here is we use cin. We talked about cin, and we are reading an integer into a bracket I dot v. Now remember, what is A? A is an array of structures. What can we do with arrays?
Access them.
We can use the indexing operator to access a particular element, which is the index, which is this part here. So a bracket I together means it is a particular element of this array. But since this is an array of structures, an element is a structure. What can we do with a structure? Specify a member to access, right? And V is a member of this particular structure, which is of character type. So that's basically saying, okay, let's read a character into member V of element I of array A. That's basically what it's saying. The next line is the most interesting one. It says, oh, let the PTR, the pointer of this particular element, point to the address of the next one. So what does that really mean? Well, it doesn't hurt to draw a picture. Okay, so let's say we have this very small array of 4 elements. Okay, each element is not an integer or a character on its own. It has 2 components. So it has a V component and a PTR component. The next one has V and PTR as well. And this one has V and PTR, and V and PTR. Is that okay? So this is array A. This is index 0, index 1, index 2, index 3. We still doing okay so far with this picture? The first statement inside the loop, which is line 22, is pretty easy. I'm just reading a character into the member V of a particular structure that is an element of the entire array. Okay, fine. We'll store the ASCII code of A here. Supposed to be ABC here. What about PTR? The second statement, which is line 23, says I'm going to use the address of a bracket 1, because I is 0 at this point, and store the address over here. So that means as a pointer, it points to this guy. Are we doing okay so far with that concept? Okay.
Because it's just saying the address from that structure is equal to the address of that other structure.
That is correct. The address of one structure is stored in the member of another structure.
Yeah, so it's like each array or each structure has a pointer to the address of the next structure.
That is correct.
Okay.
It's kind of like, when you play, let's say, a spy game, okay? You might leave little clues for spies to follow, and at every single stop, there's an envelope, right? So the envelope may have a payload, which is an instruction, and it has a GPS location of another envelope. So this component here, okay, line 8, is basically saying, okay, here is the GPS location of the next clue.
Yeah.
And each clue can potentially have the GPS location of yet another clue. So you can make a chain of these clues. That's what I'm doing here. Hello, Janet. Thank you.
You're welcome. Excuse me.
This is my cap and gowns. If anyone is anyone graduating this semester? Are you guys going to walk?
No.
No, no,
Not yet.
yes.
Is it too late to sign up?
Okay. I do not know. Okay, but I'm doing this for you. I'm the organic furniture. When you walk through the stage, there'll be a whole bunch of people down there, dressed in all kinds of colors and, all kinds of, what we call cap and gown and hood and stuff like that. So I'm one of those furnitures down there.
Where do they do the ceremony?
It's an organic, self-propelled furniture. Yep, go ahead.
Where do they do it?
The ceremony.
The ceremony, when?
Yeah. Oh no, where?
Where? Stadium. Yep. They usually do it at a later time when it's shady,
Yeah,
so it's
hot.
not going to be hot. Yeah, I don't want to be in one of these things when it's really hot. It's just going to cook me.
That's what my high school is.
Say again?
I said that's what my high school is.
Oh, sorry. Go ahead.
I believe it's May 20th.
May 20th? Yeah. All right. So when I read the next character in, go through the next iteration, the B will be stored here. But what am I going to do with line 23? Well, I'm going to store the address of this element into the PTR member of this one. So this becomes a pointer that points to the other structure. So I will keep doing this until there's nothing to process anymore. So when I get to the end of array size, okay, which is array size minus 1, excuse me. So this is C, okay, and I'll do it like this one, like this, okay. And I have to stop here because at this point I have I is now 2, and array size is 4. 4 minus 2, 4 is, excuse me, 3 is greater than 2, so the condition is still true. But if I add 1 more to I becomes 3. When I is 3, 3 is less than 3 is no longer true, and I have to get out of the loop. So this is the condition when we get out of the loop. The question now is, what about this guy here? It is uninitialized. Okay, it's called a dangling pointer. It is not initialized. So what I will do is on line 25, this will get a 0. Now, when the way to draw a 0 is kind of to ground it, or to basically say this is the end of the entire chain. And at this point, I'm going to do the line 26. So line 26. Okay, let's try to follow this syntax here. This picture is correct. Okay, so far we have the correct picture, assuming that 1, 2, 3 is the actual input. So on line 26, what is this program actually going to output? You look at the middle part here and go like, well, that is way too much. I'm going to give up on this question. There's no need to give up on this question, because when you look at each symbol and each operator, you know what it means. It's just a matter of figuring out how to combine these things, right? So where do you start? You start with the innermost part of the parentheses. What is the asterisk here? It's called the reference, which means follow the address and find that thing, right? Where is PTR pointing to?
Which one?
PTR as a variable, as a local variable, not as a member. Did we change PTR since line 17? Does PTR appear by itself on the left-hand side of any assignment operation? Nope. So PTR is still pointing to the very beginning of the entire array. So PTR as a local variable is pointing here. Is that okay? All right? So the dereference is really literally saying follow this pointer. Okay, so now we are talking about the first element of the array. Okay, what is the first element of the entire array in terms of type? It is a structure. And as a structure, what can we do with a structure? We can refer to a particular member, right? So that's what this .ptr is for. So this .ptr applies to this first. So .ptr is now referring to this thing here. It is a pointer. What can we do with a pointer? A few things, but one of the many things we can do is to dereferencing, which is the second aspect. Well, I should say the first one, but this is the outer one. That's why I said the second one. But this is another dereference. So we are following. To dereference a pointer is to follow a pointer. So I'm following this pointer, and it goes like, oh, okay, pointer here. So now our focus is the second element of the entire array, which is a structure. What we can do with a structure is to refer to a particular member. In this case, we're referring to the member V, because this is outside of all the parentheses. So the dot V applies to the second element of the entire array, which in this case has the ASCII code B, and that is what is going to be printed. So if you type ABC on the keyboard, when this program runs, it will print the second character before it returns. Yep.
So the reason why it went to the original part, it pointed to the very first structure, is because you called PTR equals A to begin with?
PTR equals A makes PTR as a pointer point to the first element of the entire array. Yep. All right. So are there any questions about number 5? No? Okay. Let's take a look at number 6. This is number 6, and the question says, write code here to find out whether the numbers stored in A, B, C, D, E are sorted. So that A is less than or equal to B, and so on. Print a message to standard output file, the variables are sorted, or the variables are not sorted accordingly. And this one has extra constraints of what you can do. You are only allowed to use the following constructs to get full credit. You can use a for loop, okay, 1, okay, this A is basically 1 for loop. Assignment statements, expressions, increment, dereference, array indexing, comparison, but you can do all kinds of comparison depending on what you want to do. You can use variable I, variable sorted, and variable addresses. Standard std : cout, std : and L, conjunction and disjunction and negation. Interestingly, you cannot use the following. You cannot directly refer to variables A, B, C, D, E, or any conditional statements. You cannot use conditional statements. Okay, so are there any questions about the restrictions? So given these restrictions, I want you to find out whether the numbers are sorted or not. And this is the code that is so far given to you. And how would you do this? Well, let's look at the code that is already given to you. Let's start with line 13, 14, 15, 16, and 17. What are we doing with those? What is addresses as an array? What is the type of each element of that particular array? Look at line 9.
An array of pointers.
It is an array of pointers of integers. Okay, so each element is a pointer to an integer, which is a fancy way to say that each element of addresses is the address of an integer. That's basically what it's saying. But all local variables are not initialized. So initially, they just contain gibberish content. And that's why we have the initialization of line 13, 14, 15, and 16, and 17. So collectively, what do you think these lines are doing? We're storing the addresses of the integer variables into elements of the array addresses. Is that okay? Because we are taking the address of A and store it into the first element of addresses, and so on. So from here on, we really do not have any need to refer to A, B, C, D, E anymore. So from line 19 to line 22, what do you think this particular loop is doing? It's doing a cin. We know what a cin is. It is representing the standard input file. We know what the greater than means because it's just reading something into something else. So what are we reading into? Are we reading addresses or are we reading integers?
Integers.
We're reading integers because what is the type of this whole thing here? What is the type of this part? It is not the address of an integer because we have the dereference. When you dereference an address of an integer, you get an integer back. So we are actually, in fact, reading integers that storing those into not the array, but what they point to, what each entry points to. In effect, we are reading into A, B, C, D, E, but going through an array of pointers in doing so. Are we okay so far with that concept? So now that we know we actually have values in variables A, B, C, D, E, and we have an array that stores the addresses of A, B, C, D, E, how do we make use of this in order to confirm one way or another whether the array is, not the array, but whether A, B, C, D, E are sorted or not? Okay. I might have missed something here. Oh, variable sorted is listed here, so that's good. All right, so let's go ahead and do this. So I said the for loop can be done, okay? You can use a single for loop, so we'll use a single for loop here. We'll say, sorted is initialized to true to begin with, so until I find a reason to believe otherwise, I'm gonna say we'll assume it is sorted. We start with the first one, so I is reinitialized to 0. We stay in this loop as long as sorted is true, okay? Because the first moment I find out it's not true, it's time to get out. And I as an index only has to stay from 0 all the way up to 3 in this case. Because every time I go through this loop here, I'm comparing two elements. So the last iteration should be comparing addresses bracket 2 and, let's see, it should be 3 and 4, so that should be 4 here. I should be less than 4 because when I becomes 3, I'll be comparing the last two entries in the entire array. For each iteration, I want to increment I at the end of each iteration. This is the post operation. So what I need to do inside the loop is to basically say sorted as a variable is going to store the following value. Is the thing pointed to by addresses bracket I, is that less than or equal to the thing that is pointed to addresses bracket I plus 1? That's all I need to know. Because if this is true, we'll stay in the loop. If it is false, sorted becomes 0, and we will get out of the loop because of the condition of the loop. Is that okay? Yes? No? Okay? All right. So when we need to get out of the loop, we just have to make use of sorted to print a message accordingly. So according to this, we can use cout on and all related operations. Okay, so we'll just go ahead and use a cout. Wait, hold on a second here. But I still need to decide which message I want to print out, because I'm supposed to say the variables are or are not sorted, and yet I cannot use a conditional statement. How do I do this? Ternary operator, exactly. So we'll do this here. Std cout. The variables, oops, double quotes. The variables are, okay. And then this part is the part that relies on the ternary operator. If it is sorted, specify an empty string. If it is not sorted, say not. And the rest is just, sorted. And then the end of line, like so. So that means this part here is not conditional, okay? It will always start with the variables are and then a single space at the end. The last part is also unconditional, which means this part here is always going to print sorted. The only part that is quote unquote conditional is this part here. Depending on whether sorted is true or not. If sorted is true, then I'm not going to say the word not. If sorted is 0 or false, then I will print the word not to form, the variables are not sorted, but that's only when sorted is 0. Is that okay so far? That's it. That's the entire, solution to this particular question. Yep.
So on the for loop statement part, does it have to be 1? Like why 1, not 0?
Because I'm getting out of the loop as soon as I find any reason that it is not sorted. So instead of assuming everything is not sorted and prove that it is sorted, I'm doing it the other way. Assuming everything is sorted, and I'm just looking for a reason to think it is not sorted.
Okay, so because if it wasn't sorted, it would be sorted equals 0, and then it would exit the loop, right? Okay.
Yep. All right. Well, let's check it. Let's see if this works. Okay, so GCC G++-G-O G6 Q6 Q6+P, and it complains about line 72. Oh, yeah. That's a leftover from something else. There we go. And it's still complaining about this one. It's invalid operands of constar 4 and constar 8 to binary operator. Okay, I just need parentheses. Let's give it something that is sorted and see if it prints sorted. 1, 2, 3, 4, 5. They are sorted. Give it something that is not sorted, which is 1, 3, 2, 4, 5. It is not. They are not sorted. All right. Are there any questions? We have just covered all of the questions from the actual final exam of the previous semester. Yep.
So the final is going to be format like just on the computer through Linux?
Say again?
So the whole final is going to be through Linux?
No, you're gonna do it on paper.
So that was just for demonstration.
Yep.
So you can compile
Yep.
stuff.
This is a paper exam.
So when you give us like a question where we're going to have to write code, we're just going to have to write on paper?
Right. There will be space left for you to write code, or if you want to attach an additional sheet of paper, that's okay with me as well.
This is GDB?
That's your G++ and GDB. Yep. It is open book and open notes. You can bring any notes. You can bring any book you want. Anything that is either printed or handwritten prior to the test, you can bring it in. That would include all the programs you have done so far, all the programs I have done so far, and everything they can scour and find and print from the internet. But I would suggest not to bring too much, because if you bring more stuff, it is harder to find stuff within that pile. So you have to. It's a trade-off kind of thing. You have to find out what is the sweet spot for you. Any other questions?
How many questions are there?
I would say about 6. So in terms of the total amount of time, which is 2 hours, and in terms of difficulty, it'll be about the same. If you okay, is that a cliff note or something like that?
Is that okay?
Yeah, that would be fine. Yep. Go ahead.
How similar is our final going to be to that one?
I do not know yet.
Please, okay.
I do not know yet. I mean, how is this one? How is this particular exam?
You're gonna study.
Huh?
You're gonna study.
I think when you do your homework assignment, especially the last one, actually it did demonstrate most, if not all, of these concepts: the addresses, the structures, arrays, recursion. Okay, so if you did the homework assignment and actually spend time to think about it, you are actually studying for the test already. Go ahead.
Which copy of the practice one are you looking at?
This is the last link. When you
The
go
last
to
one?
practice final exam.
Because I downloaded that one.
Yeah.
And my Q4 is different.
Your Q4 is different.
Yeah, look at it.
There's the practice and the actual. Can you get out and look at the folder name? Okay, so you're looking at practice,
Yeah.
not the actual.
What time of day is the final again?
So it's under.
It is the same as the schedule, so
Oh, it's on the internet?
it's on the internet. It's in your syllabus.
Okay.
Yep. All right. Well, I'm gonna stop the recorder. Have everything uploaded.
No problem.